of the conversation. So I'm going to be moderating. Orchun will be showing the live demo itself. And basically, we will do a couple of sections. If you have any small questions in the meantime, feel free to pop them in the chat below, and then I will ask Orchun on your behalf. And then we will still have another 5 to 10 minutes at the end as well for a Q&A session as well. So feel free to either send the small questions during or the larger questions after. So on that note, Orchun, nice to see you.
Nice to see you as well, Peter.
Excellent. So before we get started, I wanted to give a quick introduction about you as well. So Orchun is actually has spent almost 20 years in the solar business. So he is a co-founder and managing partner of both Solarian and PVX. He is actually leading efforts into how to simplify solar adoption through cutting-edge engineering, consulting, and software products, which already contributed to more than 5 gigawatts of projects being built globally. So, Orchun, welcome. My name is Peter. My name is Peter Pongratz. I'm the founder and host of one of the solar podcasts called Soliverse. And I also help companies such as PVX expand their markets and basically build their presence on the European market. So, Orchun, on that note, the floor is yours.
Thank you. Thank you, Peter. First of all, I would like to thank everyone for joining our webinar today. It's really valuable for us. Before we move into the how we do stuff in CAD world, in designing world, I would like to briefly tell you about our philosophy. It was 2017 when we first incorporated our first consultancy company, and our ultimate goal was to simplify stuff so we get things right. That was the ultimate idea. So if we can provide the tools and the consultancy and the decision metrics needed for everyone to handle power plants in an efficient way, then we can help the speeding up of this transformation of solar power. So that was the whole idea. And up until we started PVX as a software company, we had great amount of experience in solar sector. We had built many power plants all around the world. And this in return turned into a software experience. So we can share this with everybody around us. And it was 2020 that I personally figured out that the most lacking part of solar power plants is being ground to the terrain. Like we were designing solar power plants not based on the terrain, but we were doing it on the sheet or an AutoCAD. And then we went to the field and tried to apply it. And this came with its own friction. And that's why PVX came to be. And here we would like to avoid it. We would like to take ground as our ultimate truth and build everything upon it. And today I will show you through the mostly civil part of PVX so you can get an idea about how we handle the terrain, how we handle the design approach, and give you an insight about what you can do and what you can't do in the field. So Peter, what shall I do? Move on to the AutoCAD side or?
Yeah, let's pull up AutoCAD, and maybe I will throw in the opening question as well. So, as Orchun, you mentioned, most companies are focused mostly on the layout and generating the layout. But based on your experience, why is it more important to take a look at the civil works first and then shift on to the design?
Because when you first design something in two-dimensional space without taking the terrain into account, then when you go to the field, you will see that this terrain is not two-dimensional, it's in fact three-dimensional. So you have to rotate the racks. You have to rotate them so you can fit into the power plant. And this rotation comes with own price tag. Like either you have to move the soil or you have to create a rack that is stable enough to be rotated that much. And this turns into some unknown question that you have to solve. Also, in some cases, the terrain is too hard to implement. And you only discover this when you go to the field. But actually, we can provide the data about how stiff the terrain is. Like it is a rock surface or it is a swamp surface. So based on this information on your desk, you can plan accordingly to either use concrete or you can use uh, pre-drilling. So you get to the point where you know this information about how you do stuff. So let me first you walk through our tool and show how we do stuff. The first thing that you have to do is to tell the software where this project is. And in our software, you can get this data from three different sources. Either you can import a KML file, which is a very popular Google Earth file, or you can import drone data. It is a LAS or LAZ file, or you can import control lines. Today, for the simplicity, I will mostly move with the KML file. Once you click the KML file, it is imported into the system and it automatically calculates the northern hemisphere, southern hemisphere, the coordinates, and everything comes in the AutoCAD. And the second thing you do is to get the elevation. So you basically select the area and set a grid resolution and import it. It talks to the server, calculates the land, and gets the imagery in the behind. So this gives you an idea of the land. So let's have a look about how it was before. As you can see, the terrain is somehow complex. Some areas for agriculture, some high slope areas, and as you can see, those high slope areas are reflected into our elevation layer. So this is the first information you have. And moreover, we have here a little table. I will make this bigger for you to see it. So you can see what is the percentage of the land and what is the slope of that percentage. So let's say our racks can be placed up to 15 degrees. Then we have huge areas after 15 degrees. Since this is our limit, we have huge areas. So those areas, if we try to put racks, then we will not be able to. Let's show you one output here. Sorry. Let's first convert this to UV area and select the boundary. Okay, let's say we have a 10% limit. Let's say we want to place them. As you can see, most of the land is not useful. So we have to play around because in its current version, it is not usable by any solar design. So what we do is we apply cut and fill to this area. So here you select the leveling and you select the area where you want to apply leveling and you apply a threshold like north, south, east, west. And based on this threshold, the software goes over and over the terrain again and finds the best way to prepare the terrain in within those margins. So let's apply it.
And Orchun, while the system works, I'm sure the audience has seen different ways of calculating cut and fill, and there are a thousand different ways out there. Why do you think that the PVX method is the right one?
Hmm, sure. Good question, Peter. Um, there are many ways that you can apply leveling, but the leveling process itself is tied to our physical world, and you have all those machinery to make the land flat. They start from a corner of the land and they either dig the soil, push the soil, or pull the soil. So you apply stuff on the level. and you apply this continuously on a continuous surface. That's how we work. That's how the machine operates. In other companies' systems, they modify the terrain in such a way that the terrain and the pile lengths are somewhat equal. This, from a mathematical perspective, creates a terrain that is with the least amount of either cut or fill, but technically not implementable. It is like they remove the soil under the racks, but you just cannot tell the machinery that go there and move some soil and go there and move another soil. They go layer by layer. So you have to do the leveling like this. You have to go layer by layer. And the way to apply this is smoothing the whole surface by taking into account of the cut and fill values. So here we apply the cut and fill here. Well, that's somewhat a big area. One sec. Let me make this larger for you. Sorry. Let me just make some space here. Okay. So basically, we applied leveling here. Previously, as you can see, we had land above 15%, but right now all those values have been lessened. We are not making the land exactly zero, but we are making the land applicable in the least cut and fill possible. So here, when you apply the cut and fill, you can see any smoother terrain. So just for your reference, if I am going to place racks here, then this whole area will be filled with racks. This is the first design approach that we have to take into account. Like, as you can see, the whole area is now filled with racks. Okay, but what about the terrain? What about the terrain? Do we have any info about the terrain right now? Like, we placed the racks, okay, now they're in three-dimensional form, but how can we move to a second phase about reducing costs for construction? Like, are we going to use any other concrete solution, or do I need to use pre-drilling, or do I need to avoid some draining systems? So here comes the civil analysis part. The first thing is the draining analysis. We know the terrain, we know its slopes. So we can calculate how the water will flow on this terrain. Okay, now we have something. If we look at this in three-dimensional form, it might be much more rewarding. Sorry for the sloppiness of the AutoCAD, by the way.
And while that file is loading, maybe Orchun, we can explain the audience, where we actually, or what do we base this data on? How do we calculate where the water will flow or where it will pool?
Well, sure. We calculate the water paths using the surface. Assuming that uniform amount of rain is going to fall on the soil, we calculate the pooling points, we calculate the subterranean glitches and waterways. So here, as you can see, while applying cut and fill to this surface, we have created a decky area. So the water, if you zoom in, you can see its direction. The water that's here will come all the way to the here. And as you can see, right now we created a somewhat heavy pooling area here. Look, all this water will come here. Also, here we have a volley-like structure that the water will come here in these directions, and it will again from here move in this direction. So this is something we have to avoid while designing the power plant. This is very essential. This information is useful in two things mostly. The first, the high voltage side, like the transformer or substation or DC combiner box. those areas have a chance of having water level high, and if there's huge rain, a high flood may come from those directions. So while designing, you design for 25 years, you design for the future. And avoiding them is one of the most important aspects of solar power plant design. We didn't have this information before, and while designing power plants all around the world, in some cases we encountered this like, okay, we have a transformer here, but the water is flooding. So we wanted to do extra civil works to avoid the water flow. And it was not nice when you had this when you didn't have this information. But right now you can have it, and it helps you to avoid problems in the future.
And Orchun, speaking of problems, we got an interesting question here from Luigi. So he's asking if we have a way to calculate the most sensible truck routes, like for heavy trucks to carry heavy components in the field. Uh, what's our approach?
For calculating heavy roads for heavy trucks, in our current design, we don't take we take those waterways into account while designing the power plant. And if this is the case, then again, you can use this data. But with respect to soil compaction, we have another solution that I would like to show you here, which is an interesting one. And Peter, most people don't believe in this solution because they think this cannot be done, but let me first show it.
Makes sense. And we actually get this on some of the demos that it really does sound like magic. But maybe if you could explain the audience simply what is the practical use behind it and how is the soil compaction being calculated?
Okay, okay. The data is loading. Let me clear the screen so everybody can see it properly. So, okay, here, second. So this is our soil hardness analysis. Let me close the image so we can see it much better. Okay, yeah, much clearer now. So we have satellites, and those satellites does not just take photos of the Earth, but they also send signals. Like we communicate through satellites. We take photos through satellites. We send various type of signals through satellite. And those signals, when they hit the surface, they bounce back. And this bounce back has a value. Just like you are speeding on the highway and the radar catches you for speeding tickets. It's the same approach. So if the terrain is very hard, like rock or concrete, asphalt, anything, the signal instantly bounces back. And if it becomes like ocean surface or any swampy, muddy area, the signal is absorbed and only a very small amount of signal is radiated back. And once you are able to process those signal scattering problem from various satellites, and once you process this data, you can inspect how hard a terrain is. And basically, we have converted this data into a usable form for solar power plants. And let's zoom in here. Okay, if it is
And
very hard, sorry,
before
Peter.
we start with the explanation, so Luigi has a follow-up question of basically he wants to identify where to drill, where is ramming possible, and so on. So this will answer that question as well.
Yeah. So okay, there is let's reason from the first principles. If the terrain is like rock or concrete or anything, we know that you cannot drive a pile. So we have to do pre-drilling and put the racks inside and use a small amount of concrete, which is the very basic solution. Or if it is very soft, if it is watery, like or sand, you can easily ram the pile and there will be no pull-out resistance, so you can easily pull it out. So you need some sort of concrete block at the bottom of the pile. So this area here, the soft to very soft, is where we need to use a concrete block at the end of the piles. And hard to very hard is an area where we need to pre-drill and put the pile inside and use gravel or concrete anyhow. So those are the edges that increase the cost of civil works. But the parts in the middle, like the medium soft, medium firm, those are the areas that we want to be. This is the area that where you can ram normally and it applies a good pull-out resistance. And we map this information into the terrain and we see which parts of applicable, which parts are not applicable. So here the orangish part are becoming softy. And do we have any rocks? No, there are no rocky, no hard area here. So the rest is the power plant is mostly useful. There are some small areas here that tends to be very hard, but this data is roughly has this grid resolution of 10 meters. So it is not like pinpoint, expect a plus 10, minus 10 in XY direction here, but it gives you a good idea about the land. So if you know there's something very hard or very soft, you can easily spot using this system.
And Luigi, thanks for dropping the image in here in the chat as well. Please allow us to take a look at this after the webinar because it will disrupt the flow a little bit, but feel free to send it to us and we will untangle the analysis that you already have done.
Yeah, and for this part, uh, people find it hard to believe if this is real because this is something that our sector has never seen before. No other tool has this feature. It's very unique to us. And I don't know any other software that offers such feature. And well, as I told you, people mostly have hard time believing it. After this webinar, please reach out to us and ask for a demo. And when you get the demo, in our demo, we have all those features enabled, like they are not gated. And use it on a power plant that you have already designed, built, on an area that you already know the software, the terrain. So you can cross-check it with what you have in mind and what the software tells you. Then it will make you believe because we have tested this feature on many different areas and it's all working, but we encourage you to test it by yourself.
And Orchun, another frequently received question that we have is what is the geographical coverage of the soil compaction analysis?
There are some areas that are uh, out of the reach. In the middle of some parts of Africa is out of reach, and some North Pole and South Pole is out of reach, and also some very desert parts of Saudi Arabia. I mean, this Arabic island is out of reach. Other than that, the whole world is covered. So if you are going to build a power plant, it is very likely that it's covered by the system.
And we have a follow-up question from Tobias here about how this actually works when it comes to forested areas. How does the signal behave when it comes to trees?
This okay. There are varieties of signal. This signal, it is like we have short waves, long waves that is penetrating through the space, and each signal has a valid spectrum. Currently, this signal is a scanning signal. Like if it is a very short wave, then it cannot penetrate. If it is a long wave, then it can penetrate further. So our analysis takes part of a spectrum, given that we have plus minus 1 meter from the surface, and our actual monitoring depth is based on this spectrum. We analyze the plus 30 centimeter from the first meter of the soil. So this signal scans the whole surface from all the way up to 20, 30 meters to all the way up to 20, 30 meters. But we are only focusing on the spectrum where the piles will land.
Excellent.
Does this explain it? I'm so sorry if it's too technical. I don't want to go that much.
Tobias, if you can throw us a thumbs up, and then if you still like to dig in deeper, we can elaborate towards the end as well. Okay, thank you. Okay, so let's carry on, Orchun.
Let's move on to our designing phase. And as you can see, we have our design here ready. Sorry, before designing the designing phase, I would like to highlight the cut and fill option here because it is also a very, very important part of our software. So, okay. What we have done in our software is in the past, we had many issues like you work hard on AutoCAD, you do your design, and then you send it somewhere, and they come back to you with many changes. In our software, we want to handle this diligently. The first thing is the way we position ourselves is we are construction ready. So with respect to cut and fill, we always ship the coordinates, the change in the terrain at that exact point, and we tell about the cubic meters of each grid. So when you ship this data to your earthworks provider, sorry, earthworks provider, the person who goes to the field and does the stuff, they know exactly like this is the previous elevation and this is the next elevation and this is the amount that they have to remove. So this is construction ready. You can just ship it to the field and they can start applying instantly. And also you might be the person who does this technical design. Like you open your AutoCAD and do all the design and everything. But the people on the other side of the spectrum is not technical. He is a finance guy or he is an investor. They have a phone, they have any browser, and they are not able to open DVG file. Most of the time, they ask you to send a PDF with the drawings and other stuff. But in our software, you don't need it. Okay, now let's do a design here.
So in other words, we have covered the cut and fill functionality, we have identified the waterways, and now we have also conducted the soil compaction analysis. So now we have our terrain more or less ready. So now we are ready to actually create the layout itself.
True, Peter. So let's create the layout here. Now we have the layout prepared for us. Let's move this somewhere else. Okay, as you can see, right now we have our design in three-dimensional form. Again, sorry for the delays in the AutoCAD file. But right now we will ship this to our colleagues, our stakeholders, so they can see it easily. So we have a beautiful design here. The racks, the spacing and everything. And our installed capacity is Okay, we have 74 megawatts right now inside this area, and I want to see it on the web. And I click Design Web and Publish. Okay, Peter, can you see it?
Yes, it's loading, so
No,
give
no.
it a
Okay,
second.
I have to change the screen. One sec here. So this is a website that you can share with your friends, colleagues, any other party that is inside this area. So here you have the three-dimensional form in the website with all the solar modules and everything. And here you can play around with the sun's angle and calculate the shading. Or you can make the terrain like greener, just like PV cyst if you're into it. So you can see how is it behaving. Also, if you want to send a movie of this, then you can, for example, take a keyframe here, take another keyframe here, and take another beautiful keyframe here. And you can just create a beautiful video of the area and send this video file to your colleague. Yeah, I really like this design.
Look, it looks heart-shaped, very topical.
Yeah, yeah. Or you can do an analysis report, like you select the area, you select the solar modules, whatever you want to use. Say this one. And table layout is okay. And inverter. So we have here, let's use this one and 60. Okay, continue. And you can generate a report out of it. It can take some time to generate report. Sorry about that, but it's generating a very nice report.
But in the meantime,
So
I guess one question that might arise, do people actually need AutoCAD to be able to view this report or share it?
no, to create this report, you have to create the design, and for the design, you need the AutoCAD. But once AutoCAD design is ready, you can just ship the URL to any colleague of yours, and they can get the report, get the financials, get the three-dimensional design without the need of an AutoCAD. So AutoCAD is the source of our data. Our design, our technical stuff, everything lives in AutoCAD. But this web viewer is an extension of it, and you can display your beautiful work everywhere. That's the idea.
So you don't have to worry about, explaining non-technical people the actual design, but you are easily able to show this to your investors, to your clients and potential clients as well.
Exactly, because it is like we are in the age of moving fast. And while moving fast, you have to iterate over the design faster and faster. And those tools help you to create the design in the fastest way possible for complex site designs. And then you can just ship them. That's the idea. All the knowledge built in. One sec, it is still generating. Sorry about that.
And maybe in the meantime, Orchin, if you jump back to
Yeah, I
the
got the report. Let me show it to you again. Sorry. So here you have a view of the site. You see the irradiation parameters, the installed power, how it is, how it was, any transmission lines if they are nearby, generational statistics, solar statistics, production analysis, and all the commentary, everything is built in it. So you can easily ship this production data to your clients, like humidity, precipitation, everything is inside. And there is also something I would like to show here that I skipped that part. Sorry. Is the financial part. So you have all the data, you have the design, you have uh, production, you have design, you have all the details. So it can show you how it behaves. Like you can change the yield and see how it is behaving. You can change the capexes and see how it is behaving. And if you want to go harder, then you can open the full cash flow for each year and you can calculate and see the leads. So you can design a power plant in AutoCAD and you don't know all the details about it. And then you can just ship it to our cloud and we can calculate the yield, the financial analysis, and everything on your behalf. And you can display them beautifully in any client of yours. So once we are done with this part, I would like to again move on to the ultimate part, which helps you to design a power plant without touching anything. So it takes some time, so I'm a little bit speeding this part up. Let me again switch to AutoCAD. So this part takes roughly 4 or 5 minutes for a 100 megawatt plant, so I will not run this over. But here, once you select the area and use our auto design feature, you tell the software that this is your transformer power. And for one transformer, I'm going to use an inverter of roughly half the power. And those are the main design parameters that I use during the design. And once it is done, let me open it, save the time here. It will give you the full design, everything, the transformers, the DC combiner boxes, inverters, all the stringing and everything inside it instantly. So you don't have to worry about, shall I put the racks here or should I put a transformer here? Where are my trenches? Where are my roads or fences? Anything. You don't need to worry about them. It designs them beautifully. And as you can see from the color coding, you see that they are moving like a circle around the transformers. That is the key point because this is how cable route optimization works. We want to reach to the most circular pattern ever so we can decrease the DC losses. And the system calculates this automatically, routes the cables for you, and finalizes the design. I'm all done, Peter.
And th thanks, Orchun. Thanks for the presentation. So, on the audience side, if you have any questions, please feel free to type them in the little window here. I actually have a follow-up question on the design part. So, we have generated the design because this webinar was actually focused more on the civil works. But Orchun, if you can please say a few words about the stringing, cabling, and the electrical part as well, which we will do a separate webinar on later as well.
Sure, yeah, we can do a more detailed webinar for the electrical part about how you place. I mean, if you want to do the manual design, we have all this stuff here ready for you. Then you can go over devices, DC coupling, stringing, and everything. But this is not the subject of this webinar. In the next one, we will be showing this to you. But right now in auto design part, the AI assisted part, this is being taken care of. So we don't want people to go over again and again and do the design. but we want to handle this for you so you can iterate. Like, how many megawatts shall I fit? What is the capacity? What is the earthworks volume, etc. So you iterate on the part of the power plant that has most useful for you, and you handle the this detailed complex part to the software so you can focus on your core task.
Indeed, indeed. And I guess there is probably one more question unanswered on this note. What is the actual output of the whole design process? So what comes out on the other end?
Okay. So basically, the first output is the DVG file itself that includes the modules, inverters, the design, the terrain, and everything. And all the cabling is in the DVG file. Like, it is one big CAD file for you to ship anywhere. But also we are connected to other softwares. The first thing is the terrain part. You can export this terrain into PVSys. It is the XYZ value of the terrain. So you can get the terrain in PVSys. This is PV Collada. Currently, this is the first version of PV Collada that we mostly export into PVSys, and it does the yield analysis. But right now, I am also in the team for PV Collada version 2. And in the future, and hopefully in a year, we will have PV Collada version 2 that has all the information of power plants so you can ship your designs between either cloud software or AutoCAD software. We can also export our designs to KML. So in Google Earth, you can view them, or you can again ship it to your client. The web part I just showed you, it is an extension of PVX, so you can easily use it. Also, you can export the cables, the rack pile lengths, pile coordinates, and all this civil information data is also here, and you can use it on the field. Also,
Nice.
sorry, Peter, I forgot to mention, we have a BOQ list export here. You can also export the BOQ of the system, like the modules, the racks, and everything you need.
Excellent. And we actually have a question here from Shukru. So he's asking, the PVX right now can handle the design process from beginning to the end, but what are maybe some of the new upcoming features that are on the roadmap that people could be curious about?
Well, the features that we incorporate into PVX are mostly compiled from the needs of our clients because we are communicating with them daily. And our most priority is to make their lives easier. We want to be the iPhone of solar power plant design. We are not going into the Android way of making things complex and adding and throwing more settings and more menus inside. Although this is what we have been doing in the past year, but we will be simplifying our features, and PVX will be eventually much more simplified and easy to use while having all the capabilities you can do right now.
So in other words, the goal is to get to almost 100% automated design flow, but still maintaining the flexibility to be able to do the final tweaks yourself, depending on your complexity of the project as
Yeah,
well.
exactly. This is the problem we had in Solarium. Like, teammates joined our company and then they left the company, and they took their knowledge with them. Well, they wanted to start a new life. Nobody is blaming them, but as a company, you start from scratch. You teach people, or you either have to find the people that knows how it is done. We are trying to make this transition easier. Anybody that doesn't have an in-depth knowledge of solar shall be able to design a power plant without any effort. And that's our goal, like simple, working, and everybody can do, and no hassle at all.
Indeed. So that's kind of the mission statement as well. But as I can see, we are running out of time as well. Are there any further questions from the audience? Feel free to ask them in the window. And in the meantime, a couple of last words. So I know we've talked about a lot of things here already, But if you would like, please feel free to reach out to us to schedule either a demo or we can provide you with a free trial as well. We will, of course, follow up after the webinar via email, and we will also be sharing the recording and also the transcript with you as well. So please feel free to do so.
Thank you, Peter.
And any further questions?